So let's talk about this Alexa thing, building an Alexa skill. So differently to Siri, for instance, even much different to what you can do with Cortana, Amazon opened that system up from the very beginning. And they built what they call the Alexa Skills Kit. There's a Java version for it and a Node version. But you can actually use any kind of programming environment because it's just JSON that's being exchanged. With the Alexa Skills Kit, it just makes your life a little bit easier. So there are different versions of it. There's a big cylinder, a small one. But in fact, they all work pretty much the same. You just plug them in, you use your Alexa mobile app, it could be on Android or an iPhone. You connect it to the Wi-Fi system, and that's all what's needed. And what I would like to go through with you guys tonight is building a very, very simple skill. And we just wanted to use to build a simple calculator. So how does this whole thing work? The user just speaks, Alexa, ask calculator, what is 1 plus 2? Alexa would be the hot word that wakes the Alexa up. It's constantly listening, but it's only listening for the hot word. So I know that there are certain people who have real security concerns, but it's not listening to you all the time and streaming that information to Amazon. It's only after it has recognized the hot word. And that is only recognition that happens actually on the device. You can modify that hot word by, well, you can choose from Echo, Amazon, or Alexa. Those are your choices. So in the setup program in your mobile phone, you can select which one you like. Those are the only 3 words that the recognizer recognizes on device. After the wake-up word is recognized, that's when the device starts to listen to you and streaming all the information that it's recognizing to Amazon's server. So it's a sound file that has been sent to the Alexa server.
I'm sorry, you have a security concern question. Are you aware of anybody that has compromised this so it can be turned on covertly and listen to everything going on in the house?
I don't know of anything like that, right? And well, you could easily monitor the network traffic if that's really a concern to you, right? Look at the router logs, for instance. But the indicators here are the red light if it's in the muted state where I have it in now, so it's not even listening to the hot word right now. Otherwise, you see it coming on blue, and that is the state where it's listening to you. So we have an interaction model uploaded into the Alexa server, and that is what's used. The interaction model has everything we just talked about: the sample utterances, the intents, and the entities. So that is what's used to now generate that JSON document. And that has been sent to my server that now has to handle the business logic. So I'm getting a JSON document that has an intent clearly identified. I call it calculate. It has slots. Again, think of slots like the other companies called it. And the slots would be like I have 2 operators, A and B, with the numbers 1 and 2 populated. And I have an operation that's called plus here. So I'm building now my business logic, and I calculate the result. I'm sending a text document back. So I'm sending a JSON document back that has a text string inside. And that text string has now been synthesized, again at the Alexa server. And now the sound file is sent back to my Amazon Echo, and it's what's played. So Amazon's Alexa server does some really incredible things for me. It does a speech recognition. It does a natural language understanding based on the interaction model that I've uploaded. And on the way back, it also synthesizes the information that I wanted to synthesize to be able to play it back to the user.
You registered the calculator part there.
So calculator is what we call the invocation word, right? So there's the wake up word, Alexa, and then somewhere I have to mention my invocation word, and that tells the Alexa server which services has to use to acquire the business logic and the response. Now there could be multiple skills all being called calculator, but it's now the user's choice which skill does he want to enable. See, both of us could build a calculator skill. Maybe yours is much better, so user pick yours. So there's kind of a skills store, exactly the same way you have a Play Store and an App Store, where users can select which apps or which skills they would like to activate. This can also be done by voice now, fortunately. So if there's only one skill in that word, you just say Alexa, enable the calculator skill. And then, in that case, you don't even have to use the mobile phone and look through all these skills that are available. So again, it's your choice. You can build it in Java, you can build it in Node, you can build your own system that's just consuming and producing JSON. If you go with Java, and I've picked Tomcat here, you have to have a valid SSL certificate on that server. It's not really hard to build one. Use OpenSSL and KeyTool to build your own Java key store, and then you can easily reference it inside of Tomcat. Just configure your connector for port 443, and then you have it responding to HTTPS requests. And if that was too fast, that's also on my site where you can follow through the steps, how to get an SSL certificate, how to put it into key store, how to put it on your Tomcat server. But now let's go to the building a skill real quick here. So we come up with some sample utterances. I say, what is 2 times 3? Tell me what is 5 divided by 2. Please calculate 11 minus 5, and so on. So the more sample utterances you have, the better. Now we take the sample utterances and we replace operators with kind of variables, with entities. Just give them a name and you put them into curly braces. You see it again? So we have our sample utterances. Now we have to look for what is an entity in here. So 2 and 3 would be entities for our operators. Okay? One more time. All the numbers basically become operators. And so what else do we have to do? We have to identify the operation. So plus, minus, divided by, and so on. And we put these operations into dictionary. That becomes a custom slot. And again, we put curly braces around that thing and call it operation. It's too fast. So now we have our interaction model contains the intent. We call it calculate, and we have 3 different slots: operator A, operator B, and operation. And then we have one custom slot type that has all the different operations that we want. And then, of course, we have the sample utterances. And those 3 things the interaction model contains. So we have the JSON document describing the intent, or intents if you have multiple. You have your custom slot types, and you have your sample utterances. And you upload all that into the Alexa server. Let's break this real quick here and look at how this works. So that thing is called the Alexa developer council. And here you see all the different skills that are there. Maybe just the first one, the calculator. And let's go through this quickly. This is how you fill your definition for it. So you go into this developer console, the developer account is free, there's nothing you have to pay for it, and you just define your skill. So you say what language it is, since they just opened it up for German and for the UK as well. You give it a name, I call it calculator, and you give it an invocation name. The invocation name again is how you address it when you talk to Alexa. Then next tab is the interaction model. And here's that JSON document that describes the intent. Call it calculate here. And then we have our three different slots. Operator A, B, and operation. Down here, you see the custom slot type. Scroll down a little bit. You want to add one, you just add it. It's just a text file. And if you wanted to add percent to it, you add percent to it right here. And down here you have the different sample utterances. And I added one, we will go through this in the next step here. We added one more intent to check prime. So that here is, we ask it, is that a prime number or not? So you see sample utterances, is operator a prime number? Or is operator prime? Or tell me is operator prime? And you start your sample utterances always by the intent name. Okay, intent name is up here, we call one calculate, and down here we edit another one, check prime. Configuration. Here you define your endpoint. So that's just the URL of my server and my web service. You can do account linking, which is a little bit more difficult, and we will talk about this a little bit later. So here's your SSL. Just say my server has a trusted SSL certificate. You have an option to test your skill. So you can enter a test. Enter what is 1 plus 2? Here you see the JSON document that has been generated and will be sent to your server. And here you have the JSON document that my server produces. It says 1 plus 2 equals 3. Very small. So it's a nice way to test your application without having to talk to it all the time. Finally, there's publishing information, and that's only important if you want to really make this skill publicly available for others to try, to enable on their boxes. As long as you're in this developer state, only you on your own Amazon Alexa device can try this. I should say you can try with all the Amazon Alexa devices that are currently registered with your account. So if you have like a small Alexa and a big one, if you have the Echo Tap, which is the speaker where you have to tap before you speak, or if you have the Fire TV, for instance, with the voice remote, that's also an option. So all these devices you can use if they're registered to your account. And that's pretty much it. So that is what's happening if you define your skill, you give it a name, an invocation name, and you upload that interaction model. Now you may see already a little risk here. We upload that interaction model onto the Alexa server, but the code, the business logic runs on our own server. So there's always a good chance that that stuff gets out of sync. Add a slot here, you forget to add it into the interaction model. Or the other way, I just said, oh, we could add percentage there. But without putting it onto the business logic side as well, figuring out how to calculate percentages, it's just breaking the system. hard sometimes to keep these two things in mind. So that is just how you configure the service on the Alexa side. So make sense? We have our action model, again, with three things: the JSON document for the intent, our custom dictionaries if we have some, and the sample utterances. There are a couple of built-in slot types. So there's, for instance, Amazon number, and Amazon is just the namespace for it. So just as we just created our own custom slot type with the different operations, plus, minus, divided by, times, there's a couple of slot types predefined for us. One is for time, and you can see what the sample utterance for time could be like. Right, 4 in the morning or 4 a.m. There's a predefined slot type for date, today, tomorrow, or just a month. There's one for a 4-digit number. It could be very important if you wanted to maybe ask the user for something like a key. So maybe you don't like it if somebody can walk up to your device and say, hey, what's the balance of my checking account? So if your landscaper would talk to the kitchen window, he would figure out what's the balance of your checking account. So you could say, welcome back, Joe. Tell me your private key. Right? And then you say 7789, whatever you want. So that is one of the reasons why you see the 4-digit number here. Then they have a predefined type for US first names for all the states and for all the cities that are larger than 100,000 population. For everything else, you have to build your own dictionaries. And then there's a couple of built-in intents. So we just defined the intent for calculating and the intent for finding out if it's a prime number or not. There's a couple intents that are predefined. And the benefit you get out of that is you don't have to provide sample utterances for them. So that would, for instance, be like the help intent, where users could ask, Alexa, help me. I don't know how to use that skill. You have to provide the implementation for it. So the business logic, you have to provide the intent handler that can handle that help intent. But you don't have to provide the sample utterances. And all these standard intents here, they don't have any entities, so no parameters being set. But one intent that's was added not too long ago was a repeat intent, which is very important, where maybe it was so loud that the user could not understand it. So you can just say, Alexa, repeat it. Again, you have to write the intent handler for it. You have to somewhere store what your last utterances was that you sent back to the Alexa speaker, that you can repeat it. So we have cancel, help, next, no, pause, previous, repeat, resume, start over, stop intent, and yes intent.
Is that this total intents for this?
That's all the built-in intents that you get basically for free, again, without providing your own sample utterances for them.
You actually want that to be small because you want it to be, like if you think of voice as multiple choice, the more choices you have, the more chances you can get it wrong. Right? So you actually want your intents to be fairly narrow.
So play is not an intent.
Play?
Play.
Well, you build it if you have something that you want to play.
I was just playing Johnny Cash
Yeah.
this morning. So I'm trying to think what I said. I said, Alexa, play Johnny Cash, Ring of Fire.
Yes. So, but see, that skill gets handled by, depending on what you have set up. It's also one of the, I think, beautiful things that Amazon did. There's the Prime service, where you get like all your, if you have an Amazon Prime member,
Yes.
and you say play Johnny Cash, by default, it would play it from Prime Music.
Well, that was my disconnect because I looked at the intents. I didn't see play.
Yeah.
Because it's not a default intent, it's an intent of
But you could configure it with your Amazon mobile app to make Spotify your default DM. And that, if you did that, and if you say play Johnny Cash, it would play Johnny Cash from Spotify. So even, look at it, they have a competitive service, but they allow you to choose that over their own, make it a default skill. So, but that play intent is implemented by the Spotify service or by the Prime service playing your music. It's not a default built-in intent. And again, you have to handle them. If my calculator skill does not handle the help intent, so you can say help all you want, without you implementing that intent handler, it will not give you help for that skill. So again, we have to differentiate. The interaction model lives on the Alexa server. The business logic happens to run on your own. So what happens now on your own server if you buy into this Alexa skill kit? The Java version has lifecycle handlers, which may look very familiar if you ever have implemented a servlet. So you have in session start, lifecycle event, you have an on launch event, you have an on intent event, and you have a session ended event. So now how does that look? The first time a user accesses your software, the first time the invocation is coming in, that on session start event is fired. And so here you can, for instance, try to identify the user, maybe find him in the database and do stuff. Then you have two different ways how you can interact with the skill. One is without mentioning an intent. So I could just say, Alexa, talk to calculator. And this is when the on launch event would be called. So I'm just calling with my invocation word calculator my skill, but I'm not giving any other clues what I want from that skill. And this is typically used if you want to have a longer conversation with the skill. And then you could say, well, welcome back, Joe. And it's also a good time to prefetch all the data you can from your backend database. But you could also say, Alexa, ask calculator, what is 1 plus 3? So now you give the wake-up word, the invocation word, the intent, and all the entities all in one sentence. And so now after on session start, it would immediately fire the on intent event. And then you decide with your response. You can say, I would like to keep the microphone on. I would like to keep the session going. The user can see it because the blue ring is still on. So that will allow him to ask a follow-up question. Or you could just say, no, I want the session to end. And so you would tell him the result, the thing would go back to sleep. And then the user has to start all over again. He has to start waking up the device. Alexa, talk to calculator. What is 5 times 5? I get my result. The thing, again, can go back to sleep. Or you decide as a software developer what should happen. Do you want to keep listening? You want to keep the conversation going or not? And there's one more cool thing that they allow you to do. They call it a reprompt. So when you send your response back, say 5 times 5 is 25. And you let the microphone on, blue light keeps blinking. You wait for a follow-up question. The user doesn't give you one. It waits for 7 seconds and then it plays a reprompt. So when you respond, you can send it the original response plus an optional reprompt that will only be played if the user remains silent. That's just a trick to keep the conversation going, if you want your skill to do that. So here you see that stuff just in code. On session started, on launch, on intent, and on session ended. That's all you have to implement for your skill. And, well, one more thing. How do we respond? So we built our response object by providing the text, which is called here speech 1, for hello, I'm your calculator. And then you can also do what I put then in the reprompt. If the user doesn't respond, I say, I can perform simple addition and subtraction and so on. So let's just try this out. Alexa, talk to calculator.
Hello, I am your calculator. I can perform simple addition and subtraction, and also
That happens sometimes. I think my power brick is not strong enough. I picked the wrong one. So, but you saw the idea here. You can try to help the user. If the user doesn't know what to say, you have 7 seconds. You can either time it out at that point, not providing a reprompt, or at least try it one more time. Maybe give a little bit more context, what your skill can do. So let's go quickly into an Hello World example here, where,
hello.
so that was a reboot basically, where I put the stuff here all in IntelliJ, and that is how the project looks like. So I put all these files that I need to build the interaction model, and I just copy and paste that into the Alexa console. The BAF file contains all the sample utterances, the JSON is the intent definition, and then you have the skill.txt file which has all the custom dictionaries. So our business logic just sits in one class called skill. We have to have a web.xml, and then I show you the Gradle file to build it on. So that's what we want to IntelliJ. So here's the whole project. It's in GitHub. You can pull it down if you like. Take a look. And maybe let's start with the Gradle file. So the beginning here is just to allow me to use SCP to copy the file onto my server. So I just define my remote host and how to deploy it.
Make that a little bigger.
If you go to view, there's a presenting mode. It's actually under view.
Is that better? So this just defines the host, where it is, where my key is, and it defines just the deploy task. So I can run this just as a Gradle job. Depends on building the WAR file first. Then we have standard servlet API. This is Alexa Skills Kit. Common language and common codec are typical Apache projects that you need. The Alexa uses an older version of Jackson. And we need a logger, and that's pretty much it. So the dependencies are, I think, rather short here. So let's go into the skill. So this is my basic logic. Like I have a calc method, static. It receives the operators 1 and 2 in the string for the operation. Code smell. We have another one to calculate a prime number, but that's not the interesting part. So the interesting part is where what do we do on session start? I do nothing here. I just log in. You get a user ID with the request, and the user ID is the same every time that user comes back to your skill. But it's unique for the user and the skill. So if you have two skills, the same user will appear as two different users in these skills. So Amazon does not let you allow really to identify the user using multiple skills. So you can track one user, and that is a good thing. You can behave differently if you have a user that comes back to you frequently. But if that same user visits another one of your skills, you have no way to identify it. If you don't do another form of handshaking. But just that user ID that Amazon provides you with in that on-session start here does not allow you to do it. So what do I do here? On launch, this is when we don't know what the user really wants. He started it with just using the wake-up word and the invocation word without giving us a clue what intent should be performed. This is when we just say, hello, I'm your calculator, and we have a reprompt giving him a little bit more information. And this is an on-intent method where we know what we want, so we ask, is the intent name equals calculate? Or down here we say, is the intent name equals check prime? And then we perform a different step. We receive a map that contains what they call again the slots. That would be all the entities. We parse them by name. We look for operator A and B in operation. And then we just perform the calculation and send a text file back. And here we decide what we want to do. We can say, should session end or not? So I say, end my session. I say my result, the microphone goes dark. If I say false here, should session end false, then the system will remain on, the microphone will remain on, and the session is still open to my application. So the user does not have to say Alexa again. He does not have to say calculator. He can ask for the next calculation it will perform. That's the difference between shutting down the session and letting it. The definition of Alexa session is for as long as the blue light is on. So as soon as you stop that session, the light goes off. The next time the Alexa comes back, you have a totally new session. So if you want to keep state over more than one conversation, you have to do that on your own. Alexa, talk to calculator.
Hello, I am your calculator.
Is 17 a prime number?
7.
Maybe if you like use less of the volume, that could. I'm really sorry. It's really the power brick. So it consumes just too much power if we have it in full volume setting.
Take USB power?
Yeah.
And for your power purposes.
What's the amperage?
I'm not sure, but it keeps this thing going when it won't go on AC. This is strong.
Hello.
Let's turn down the volume a little bit. Alexa, talk to calculator.
Hello, I am your calculator.
Is 17 a prime number?
17 is a prime number.
So it's the volume. Just run it through. So if you wanted to try this out, this is the calculator project. And again, all you need is an Alexa Alexa, and then you sign up for a developer account, and you get going. And fortunately, I think the little device is available again, $50. Not getting any commission, but I think it's a good way to get your kind of your feet wet.
It's 3.6 amps.
It's good. So what I would like to show you now is an example that we did for work with the Alexa, where we tested how good the recognition really is and how fast. So I used the Alexa in my car, exactly that little Alexa thing here, and I used my cell phone to provide internet access.
What's the weather like?
Remote, it's 76 degrees with clear skies and sun. Today, you can look for perfect sunny weather with a high of 84 and a low of 48.
Alexa,
We run
what's
the
the news?
audio output through the car stereo.
Here's your flash preview. In NPR News from TuneIn.
Live from NPR News in Washington, I'm Jack Spear.
Ballot. This election marks the first large-scale
Alexa, talk to Mindy.
I will. Welcome back. How can I help you today?
What bill should we?
I found two bills, totaling $26.26. $20.20 are due in 24 days for digital transfers. $6.06 are due in 24 days for NetCrawl LLC.
Have I been paid?
I found a $250 deposit made 4 days ago, and paid the Motorola Mobility.
What's the balance of my PayPal account?
The balance of your checking account is now $82.82.
Next.
See you later, Wolf.
So that was live, nothing fake, nothing cut out. Driving car, windows open, recognition still works very fast. And we were accessing the Mint backend system, asking for account balances and transactions. So now I would like to run you through a couple of ideas. What makes a good voice user interface or conversational user interface? And the idea is we don't want to fall into the same trap that the IVR developers fell into. Right? IVRs are, nobody really likes them. Yes?
Oh, sorry to interrupt, but on the previous video, with the echo of the car, how was it getting internet access? Did you have it tethered to your phone?
Yes, it was tethered to my cell phone.
Oh, okay.
So I think we all kind of got our first experience with the voice user interface using Siri. And we knew Siri probably long before we even tried it for the first time, because the commercials introduced us to the whole concept. We already knew what her voice would sound like and how to ask questions. And Apple said, talk to Siri as you would talk to a friend. And I think this is very telling. Nobody would talk to his IVR like he would talk to a friend. So when you talk to an IVR, you speak in commands. Think about calling your insurance company or your bank. You have an expectation of consistency. If I call the next day, I have the same utterance, you expect the same behavior. You follow a strict hierarchy. You just pretty much give it to you by the APR system. And you expect an unconcerned response. It's all different when you talk to a friend. You have a real conversation with shared control. That means your friend can take the conversation to a whole new direction if he likes. We expect that the conversation is adaptive, that there's some randomness, maybe even surprise being part of it. And we are maintaining context in the conversation, but we tolerate small interruptions. Most of all, we have an expectation of an empathetic response. So that led us to a couple of what I would call like principles to build a conversational user interface, where we want to create like randomness, surprise. We want to be adaptive. We want that the experience is personal and personal. We want to be able to maintain context. We want to have a real conversation, or at least create the illusion, and also we want to create the illusion of empathy. So let's go into these different principles here. Again, having the Alexa in mind. Randomness. So what we did here is we built kind of not just one response. For every situation, we built an string array of responses. So for the same thing, if it's a greeting or a short message, we have a couple versions of it. They're all a little bit different. And then we just use a random number generator to pick from the total length of the string array that we have. So not sophisticated, and yes, over time, the user will figure out, oh, this is one of the 4 different responses that I'm always getting. But there's still that randomness in it. Not every time when you say, hello, how are you, you get the same response. How can we be adaptive? That's a little bit more work. And just give you one example. I told you that we can figure out who that user is. We get a session ID and a user ID. So we can track that user. We can look at, is that the first time we see him? Maybe we have never seen him before. Then we want to play a little bit of longer introduction. Or is that the first time we see that user today? Or has he just been here 5 minutes ago? And so for these 4 cases, we have different greetings. Well, we have arrays of greetings, 4 different ones. So we are adaptive to when that user comes to us. Capital One has a skill on the Alexa, and every time I go there, it greets me with the same sentence. Hi there, welcome to Capital One. You can ask me for things like account balances or make a credit card payment. If I come back in 2 minutes, I get the same thing. If I come back 10 times on the same day, I hear the same thing. And that's the worst. I can go there 10 times, it will never call me by my name. So we made it a point, most of our resource strings have a variable where we can inject the name of the user. And we know that user. We know what his account balances are, we know where he spends his money, but we want to greet him by his name. And so we put a name in rather more often than not at all. Trying to be personal. So I told you earlier, you can select Alexa, Amazon, or Echo as your wake-up. And here's what a good friend of mine told me. When I switched from Alexa to Amazon to avoid a namespace collision with my daughter Alexis, the emotional feel of the device shifted from talking to a witty female computer to interfacing with the Amazon corporate machine. So only a guy from Google, of course, would call that a namespace collision, but it still tells you something, right? Giving it this female name Alexa makes it somehow more personable than calling it Echo or even worse, Amazon. Context. How can we maintain context? To give you an example, if I asked you, what were the last 3 transactions? How would you figure that out? you would probably go and fetch all the accounts that you know I have, and then you would fetch all the transactions for all the accounts. Then you sort all the transactions by date, and then you read me the most recent 3 months back. But now imagine that the question before that was, what is the balance of my checking account at Bank of America? So now, if you look at the question now, you would probably think the 3 transactions are now looked at in the context of the checking account at the Bank of America. So how can we make use of this? You can just put all these intents with all the entities onto a stack. So here you see the example. My intent is get transactions, and I have different entities, all optional. I can ask for a number, I can ask for an account type, for a bank name, or a payee. And you see that 2 of the entities that were used in the previous request, in the previous intent, are compatible. So I can just reuse them. The next request could be get deposit, meaning have I been paid? Now I find that neither of my optional entities is on the stack. I would have to go 1 level deeper to find them. I could apply them, or we think it's better to ask. So a question could be, are we still talking about the checking account at Bank of America? So if the information is too deep on our stack, we rather ask for confirmation. The answer could be no in this case, then we run the get deposit without any entities and just use a stack. It's a very simple concept of stacking all the intents and looking for compatible entities could allow you to keep context. Having a shared conversation, that's hard, but we already told you a couple of things here. I told you about the reprompt. So we can try to keep the conversation going. And here's one trick that we use that is often used by these chatbots competing for the Loebner Prize. They try to steer the conversation in areas where they have the deepest knowledge. So we can do the same thing. The user says, Alexa, talk to Mindy, and Mindy would be an invocation word for one of our Mint skills. And the response could be immediately, welcome back, Wolf. Your portfolio went up 2.7% today. Good job. So I'm trying to steer the conversation, maybe into the IRA section, into an area where I have lots and lots of content. And the user may or may not bite. Here we say, well, okay, what's the balance of my IRA? And I've already told you that when we look at the reprompt, for instance. So I can say, how am I doing on my coffee budget? The response would be,
So far, you've spent $17 in the coffee shop category and have a total amount of $25 budgeted.
so now I'm probably thinking, what can I do
Wolf,
with that
would
information?
you like to know about your restaurant's budget as well?
So instead of timing out, I make her go in the balance hierarchy 1 level up and ask if that's also something that's interesting to you. So again, volunteering information and steering the conversation into areas where we have more content is a good idea. That way the bot can also try to keep the conversation going and try to steer it, take control of the conversation. Empathy. How can we create an empathetic response? A couple years ago, I looked into how I can use special tags for speech synthesis to make an approach into creating this empathetic response. To give you a little context here, there is something that is called SSML, Speech Synthesis Markup Language. It works exactly like HTML works. Like you can tag words in HTML to be bold or italic, so you change the style. The same works for speech synthesis as well. You can tag a word for instance, with a tag that's called silent, then that word will be rendered much more silent. Or you can say, put emphasis on that word. And here's, let me just play you the result.
Hi, my name is Jackie. Here is how I usually talk. I have to tell you something. Uncle Harold just called. It's about Martha, you know. For a second, let's imagine something sad happened. I have to tell you something. Uncle Harold just called. It's about Martha, you know. And now, let's imagine something wonderful has happened. I have to tell you something. Uncle Harold just called. It's about Martha, you know.
So you heard the same sentence 3 times, and well, we overemphasized it a little bit. It's ear cons starting in at the rain, you may have heard the rain falling. But you can deploy simple tricks to make it sound sad or make it sound happy, make it sound a little bit more upbeat. So maybe you don't want to be super upbeat if you tell the user that his credit card was not approved or something like that. There's also, well, the Alexa does not yet fully support SSM. They only support a subset. So changing the emphasis, for instance, all this does not work yet. But we can do something else. We can look at the activation and negativity of certain words. And so here you see a pretty loaded sentence. I love you, but I hate your cold sister. And every word has a different activation. And so you see positive words are in blue, negative words are in red. The redder, the more negative. And the bigger the font, the higher the activation is. So just by choosing different words, you can create an empathetic response. So I would like to finish with a couple of good and maybe not so good use cases. So we now just looked at how can we make a voice user interface or a conversation user interface more engaging. But sometimes it's even more important to pick the right use case. So use cases that have a high frequency are very good. And we talked about this earlier, like the 0 to 3D user experience. It's a voice user interface. There's nothing that can help you. There's no icons that you can remember, no lists on the screen. You can only get kind of on your memory. How did I talk to that thing before? And if you use a device like the Echo frequently, you become an expert user. But if you use it only once a week, you may have forgotten already how you talked to it the last time. So ask yourself, which products or which components of my products get used every day? Those are the ones that are favorable for voice user interfaces. Dialogue length. What we figured out is users really don't like to talk all that much into these systems. They want to get a longer response, yes. But my voice input should not be really long. So if you look at your use case, look at the number of words the user has to say versus the number of words the response has. Another one is execution. So favorable use cases do more than just answering questions. They volunteer insights and advice, but they do much more. They also have to do something that is beyond just conveying information. They have to, like, sending an email, sending an invoice, doing something that is more than just giving you information through the synthesizer. Those use cases create a real sense of accomplishment. The use case has to be optimized for something. Why else would I use my voice? Maybe it's more direct. Like we talked about how chatting is much more active than talking to this thing, because I can go very quickly, my example, to figure out what a prime number is. To do this on your smartphone takes a lot longer. You have to pull out your phone, find the right app, do all that stuff. It could be that it's just the more direct approach. Or, like you saw me do it in the car, maybe it's that I can do multiple things at once now. So you have to figure out what is it why the user would choose voice over another way to get this information. Coverage, and this is super important. Can you find all the answers that are very much related to that use case? You have to have a good coverage. You cannot, like, give you an example maybe for Siri. Siri with open tables together. You could not think of, well, this thing only works for Italian restaurants on Thursday. It has to have, in this narrow use case, full coverage. So can you answer all the reasonable questions that the user might have in this domain? Thanks for listening.
Any questions?
Authentication voice, are you added to it, or are you using passphrases, or actually
Okay,
using
that's,
speech recognition?
Yes, I'm sorry I glossed over that. So what we have to assume is that the data transfer end-to-end is fully secure. And this is why they are so strict, for instance, with SSL certificates. You cannot use wildcard certificates and all that. So the information that is sent from my server all the way to the Alexa, I have to assume that this is secure. Where the problem comes in is, can you secure that device? And so let me show you, tell you how authentication works. When you enable a skill, you go into your mobile app, you say, I would like to use that skill. The skill performs a handshake with your own OS system. Meaning you provide now, in the skill definition, in the portal, an URL where your login page is located. That login page now shows up in the Alexa mobile app. The user provides his username and password. Your OS system now creates an OS token. And that token has been sent back all the way to Alexa, to the Alexa server. And now the next time the invocation word comes, with the JSON document being sent to your server, that token will be attached. Don't have a good slide for that. But you can see it maybe here. That's what's happening for the Intuit skill. When you enable that skill, we show a login screen that's provided by our OS system. The user provides his credentials. And if we say that's okay, we send a token back, that's when the Alexa service would say, yes, authentication was successful, and from now on the token is sent with every request.
But again, as far as you know, within the Alexa ecosystem, there is no voice biometric.
No, there's no voice biometric. It's not even, the first thing they would like to do is just to differentiate between family members. So the idea there is that your kids don't order things in your Amazon account. But not even that is currently working.
That is
So
not,
it's not work. There's no voice biometrics implemented in that whole ecosystem.
but you would think they would go there.
They will, well, what they're currently working on is identifying family members. So separating the voice prints from your family members far enough out that the Alexa would know that it's your voice and not your wife's or your kid's voice. But not in a way where it would be really secure to rely on that.
Gotta start cleaning up. So if you guys want to chat, keep on chatting. We can still stick around for a few minutes. But I did a little bit of a disservice